Hey guys, today we're going to build a pop can crusher out of the PVC pneumatic cylinder that we built last video. We're going to modify it just a little bit, put it all together. Let's build. Today we're going to need the PVC piston that we built last time with all the different parts. A couple more of these guys if you want, they're optional. We're going to shrink this guy down. A 3/4 cap that'll go on the end of there. And I had some 2x4 and some plywood lying around that we're going to build the frame out of. A little bit of rubber to help protect the piston cylinder. And a pop can to crush. So, and potentially a little bit more 2-inch PVC. So let's get to it. Pressure is a force, just like everything else. When you push your friend, if you push against a wall, the floor that you're standing on, you're providing force. Pressure is just a force that's exerted by a gas in this instance. The same way that pressure is like when you blow into a balloon. When you have a balloon just like this, we have pressure all around us. We live inside an atmosphere, there's air all around us, but this balloon doesn't care. He's just flopping around. It's not until we put more pressure inside of him that he blows up. So when we add pressure, we create a force, and that force is pushing this balloon all directions inside and pushing it outward. And the same thing happens when we created our piston, our cylinder. We have a places to stick pressure on both sides. And this is important because if you want to get pressure to do something for you, you have to have a difference. Right now, there is pressure in this balloon pushing it out, and there's more pressure in the balloon than there is outside of it. But the balloon's just going to sit here and not do anything. The same way that if you put 20 psi of pressure on one side of the piston and 20 psi of pressure on the other side, it's not going to do anything. It doesn't matter. What you need is you need a potential difference. And so if you put 20 psi on one side and 0 psi on the other side, now you have 20 psi of difference. And now you have movement. The same way that when I take a needle, I'm allowing the pressure from inside this balloon to move. And it creates a blast of air that shoots energy in all directions. We can calculate exactly how much force our cylinder is going to have by some simple math. All we need to do is realize that PSI stands for pounds per square inch. This is a unit of pressure. And there's metric units of pressure, there's all sorts of stuff. In this, we're just going to focus on PSI. You've probably heard of it, and it's exactly what it sounds like. If you were to take a 1 inch by 1 inch square, like this, and if you were to push exactly 1 pound, that is 1 pound per square inch. And so on, say, an air compressor, like we have hooked up to our cylinder, you know, you can go anywhere from 0 to 200 pounds per square inch, and you can do all sorts of stuff. So if we were to take, for the can crusher example, we put 60 psi and 80 psi of pressure into the one side of the piston. So between 60 and 80. So, because we know how wide our pipe is, we can actually go and find out exactly how much pressure we're pushing. And it all comes down to area. In a circle, you can find the area by pi r squared. This is just simple math stuff you probably don't remember, and it's just something I remember. So all your math stuff, just go re-look up, because I'm going to go re-look it up at some point in time anyways. So we know that we are using a 2-inch diameter PVC pipe. So that means it's 2 inches from this side to this side. Radius is half of that. That's from the middle point to the side. So our radius is 1 inch. So pi times 1 is 3.14.
Squared. Times 1.
Times 1 squared. 1 squared equals 1. 3.14 square inches. And that is how much area is inside of our pipe. So if we were to take our 60 psi number, 3.14 times 60 is what? What's 3 times 6? 180? 180 plus some change pounds of force that our piston was pushing against that can at 60 psi. At 80 psi, we just have to do the same thing. 3.14, which is our square inches of that is the area of our piston. 3.14 times 80 equals 240, we'll say 244-ish, whatever, 240-ish pounds of force. And you can see that this kind of just scales out of control. And that's why pressure is so crazy. Tornadoes create pressure. They only create a little bit of pressure compared to most things, such as a few psi. But when you think about all the area of your walls and your windows and your doors, that adds up to thousands and thousands of pounds. It's so mind-boggling. Once you can get, if you were to pressurize your house, you only have to pressurize it probably, 0.2 psi to get it to pop like a popcorn kernel. It'd be crazy because you have so much area. As we said, the push force of this piston is much more than the pull force. And that's because we have 2 inches on the push side. If you remember, we have a rod that comes out, and that blocks some of the pressure from going back. And so what we can do is we can actually take this 2 inches of area that we did before, and then we just subtract the middle amount that that rod is in the way of. 3/4 inch pipe is about 1 inch outer diameter, and we'll just use that for now. And so we can do the same exact calculation that pi r squared, this is going to be 1, or 0.5, oops, 1/2. So pi 1/2 squared is the same as pi times 1/4. When you square halves or in fractions, you can just multiply or square the bottom. So pi times 1/4 is, I'm going to pull out my phone and calculate this one because I don't know this one on top of my head. This is why phones and technology exist. So 3.14 times 0.25 is 0.785. And this is square inches. So we know that the 2-inch pipe is 3.14 square inches, and we know that the middle pipe is 0.785 square inches. So all we have to do is take the big one and subtract the little one, because we're taking away of the pressure of that first one, minus 0.785 is 2.6-ish. We'll say 2.5-ish. So our push force, we have 3.3 and some change area, square inches, pushing this way. And pull force, we only have 2.5 square inches. So we have more area on this side, as we said, than we do on that side. So when we push at 80 psi, we can produce 240-ish pounds of push force, but when we pull, we actually only get to multiply that 80 psi by 2.5, which is 200 pounds. And so that is, may not seem like a lot, but that is 20%. And if you can push 20% more than you can pull, it's not an insignificant amount. Pressure is super cool. Physics is fantastic. I love physics. If you guys want to learn more about this stuff, let me know in the comments. I'd love to teach it. I want to try to keep it built around projects because learning things hands-on and learning things how they work in the world is, I think, the best way to learn. So let us know. We're going to put a thing somewhere up in here to subscribe. And we've got the old video. It's probably going to be over in this area somewhere of how we built the piston. And as always, make on.